In chapter 6, let's take a look at the examples for chapter 6. True-false questions. Number 1, rating the satisfaction of a hotel room on a 1 to 5 scale is an example of a discrete random variable. That would be correct given the fact that we are using a scale from 1 to 5. And I highlight the fact that it's used, the scale that is used. The amount of soda consumed by an adult next month are an example of a discrete random variable. This would be false. That would be a continuous. It could be any value. The mean of a discrete probability distribution is the weighted average of the outcomes of the random variable that comprise it. This would be true. The equation used to calculate the binomial probabilities relies on permutations of n objects selected x at a time. This would be false. In a binomial experiment, the number of successes can never exceed the number of trials. That is correct. Multiple choice questions. Which of the following is not a condition of a discrete probability distribution? The probability of successes must exceed the probability of a failure. This is not the case. A novel on Amazon.com has the following ratings in number of stars from reviewers. Calculate the mean of the distribution. So all you're given are possible outcomes alongside the corresponding frequencies, which means in order for us to calculate the expected value, the average for a discrete probability distribution, keep in mind that if x is equal to n, the sum of x times f of x. The sum of x times f of x. So we have x, but we need to find f of x. To find f of x, the corresponding probabilities, we are given the frequencies. The total number of the frequencies is equal to 50. So we will calculate the relative frequency, which is the probability, for each outcome. So for the first outcome, the probability will be 7 over 50, which will be 0.14. 4 out of 50 for the second one, 0.08, 0.4, 0.18, and 0.2. They add up to 1. And now we can do x times f of x, or p of x is the same thing. So we will do 1 times 0.14, 0.14, 2 times 0.08, 0.16, 3 times 0.4, 1.2, 4 times 0.18, 0.72, 5 times 0.2, 1. We add them all, and the expected value will be equal to 3.22. So the correct answer will be B. 77% of husband-wife families with kids under 18 years old have life insurance. A sample, that means N, is equal to 6 husband-wife families was selected. What is the probability that exactly 4 families will have life insurance? So I'm looking for the probability of X equal to 4. P is equal to 0.77. We will do binomial probability since N and P are given. X equals to 4. So we will go second VARS, binomial PDF. Hope you can see it. N, comma, P, comma, X. 0.2789. So this would be binomial PDF 6, 0.77, 4, if you're doing it on your graphing calculator. For the same example, what is the probability that less than 2 families have life insurance? Less than 2, x is less than 2. We need to rewrite it in a format where x is equal to a specific value. Less than 2 means x equals to 1 plus probability of x equals to 0. So you will do binomial for each one. So 6, 0.77, 1 plus binomial PDF 6, 0.77, 0. Once you do that, the probability will be A. For the same example, what is the mean of the distribution? In a binomial probability distribution, the mean, the expected value, is simply n times p. In this case, 6 times 0.77, which is equal to 4.62. 4.62. Now, let's look at the problems. The following table shows the number of used cars sold each day over the last 25 business days at Newark Motors. We have number of sold cars and we have the corresponding frequencies. Now, the total number is 25. To find the mean number of cars sold per day, I need to find the probability. To find the probability, I need to calculate the relative frequency for each outcome. So 6 over 25.24, 2 over 25.08, and we do the same thing for each outcome. Once I have the probabilities, I simply take each outcome and multiply it with the corresponding probability. So it will be 0 times 0.24, 0, 1 times 0.08, 0.08, 2 times 0.4, 0.4, 3 times 0.12, 0.36, 4 times 0.28, 1.12, 5 times 0.08, 0.4. And at the end, we need to add them all in order to find the expected value, which in this case will be 2.36. So 2.36 for the expected value. Now, to find the standard deviation, we first have to find the variance. All right, we first have to find the variance. So, to do that, we create another column where we take the square deviation of every entry from the mean and multiply it with the corresponding probability right here. So, this will be 1.337, 0.148, 0.026, 0.049, 0.753, 0.558, and then at the end 2.871. Keep in mind that this is your variance, not your standard deviation. Since I'm looking for the standard deviation, I take the square root of 2.871, and this will be 1.694. Now, what is the probability that more than 2 cars were sold on a randomly selected day? More than 2, that means either 3, 4, or 5. So all you really need to do is add the corresponding probabilities. So this will be 0.48. 0.48. Now, Kobe Bryant, a professional basketball player in the NBA, has made 84% of his free throws during his career with the Los Angeles Lakers. Calculate the probability that Brian will make 4 or 5 of his next 6 free throws. Now, given the fact that if he was still playing, that is. So, we have P is equal to 0.84. N, in this case, will be equal to 6. And I want to find the probability that it will either make 4 or 5. That means of x to be equal to 4 or 5, which means probability of x equals to 4 plus probability of x equals to 5. This, I'm showing you if you were to use the formula, how you would plug in the numbers. If you were to use your graphing calculator, you would do binomial PDF n, comma, p, comma, x plus binomial PDF 6, comma, 0.84, comma, 5. Right. One or the other, we simply add the corresponding probabilities. So let's try to see if you can see it clearly. Second vars, binomial PDF, we have 6, comma, 0.84, comma, 4, close parentheses, plus second vars, binomial PDF, 6, comma, 0.84, comma, 5, close parentheses, and enter. So 0.593. 0.593. And there you have it. Calculate the probability that Brian will make 6 out of his next 6 free throws. So I'm simply looking for the probability of x to be equal to 6. You have how to plug in the numbers for your formula. If you were to use your graphing calculator, you would do binomial PDF n 6, comma, 0.84, comma, 6. So we would do second vars, binomial PDF, 6, comma, 0.84, comma, 6, close parentheses, and enter. 0.3513. 0.3513. Calculate the expected number and variance for this distribution. So expected value for binomial probability distribution is n times p, 6 times 0.84. This would be 5.04. And for the variance, n times p times q, this is your q, you would be 6 times 0.84 times 1 minus 0.84, and this would be 0.806. Now, according to the U.S. Census Bureau, 66% of American adults own their own homes last year. A random sample of 7 adults was selected. So once again, we know that we have binomial. N is equal to 7, P is equal to 0.66. What is the probability that exactly 3 of them own their own homes? I'm giving you the formula, and with your graphing calculator, you will do binomial PDF N, comma, P, comma, X. So once again, we will do second vars, binomial PDF, n, comma, 0.66, comma, 3, close parentheses, enter, 0.1345. If you were to round up to 3 decimals, this would be 0.135. What is the probability that more than 5 of them own their own home? More than 5, keep in mind, more than 5, your n is equal to 7. Your n is equal to 7, which means that either it's going to be 6 or 7. So this is the solution with your formulas. If you were to do your, keep in mind, you only go up to your sample size greater than 5. You do not include 5. You will do binomial PDF, n, comma, p, comma, x, plus binomial PDF, 7. And if you were to do the calculations, this would be 0.083 as well. Expected value n times p, n is 7, p is 0.66. This will be 4.62. And the variance, 7 times 0.66 times 1 minus 0.66. So this would be 1.571. Right here. So this concludes the examples for chapter 6.